Test, test. Test, test. Test. Test, test, test.
Okay. Oh, right, okay. Thank you very much for coming to this conference. On the behalf of the organization committee of ICNLSSP, I would like to welcome you to this conference. I will give you more details about the program and the organization in a few minutes. But before that, I will give the floor to Dr. Mohammed Juri, who is the founder of this engineer school. He will give us, tell us few words about the school. Thank you.
Ladies and gentlemen, first of all, I would like to welcome you in IGSGA. Business and Engineering School, created in 1981 with almost 2,000 students and about 100 researchers and teachers. Before going further, I would like to point out that due to our history, English is not our second language in Morocco, so ask your indulgence for the word that I will mispronounce, but that I hope that you will understand. Anyone, and therefore those whom I deferred, and that I do not have any doubt that you will gust. I would like to thank all those who contributed to this international conference and warmly congratulate those present here for the acceptance of their articles. Our goal, which is to perpetuate such event by programming every 18 months the holding of an international conference to give the opportunity to Moroccan and researchers from Maghreb to meet researchers from other nations. For this year, the sum of the communications that we will have the pleasure of listening is representing in the proceedings that we distribute to you. We decide that the 10 best communication will be published in a special issue of our scientific journal, International Science and General Application. I thank you for your attention and wish you a pleasant and profitable conference.
Thank you, Dr. Jury, doing this effort, speaking in English. I think that it was maybe difficult for you, but I think everyone understands what you say. Okay, thank you very much again. So I give the floor now to Professor Hisham Madroumi, who is director and the head of NSEM School here in Morocco. Thank you.
Thank you. Ladies and gentlemen, dear researchers and students researchers, I am very happy to participate with you in this international conference on natural language, signal and speech processing. It's a very good conference and a very good program in 2 days. I am very, very happy to reading this program, and we have many good paper in this 2 days, and we propose in the future and the next conference to our engineering school to participate in this organization and in the committee for scientific committee. Thank you.
Okay. Thank you very much. So maybe I will, before starting the first keynote, I will give you some details about the program. So I will take the computer. So, welcome again to ICNLSSP International Conference on. Everyone hear me? Yeah, okay. Welcome again to ICNLSSP.
Test.
Oh, so I think that everyone can hear me. You can hear me at the back? Okay. So I don't need it. So ICNLSSP is International Conference on Natural Language, Signal and Speech Processing. It has been organized and sponsored by ISGA, which is an engineer school in marketing and in computer science. So as in any conference, I have to thank a lot of people. So many thanks for ISGA, okay, which is Institut Supérieur d'Ingénieurs et des Affaires, and more particularly to Dr. Mohamed Jury, who is the founder of this school, and he sponsored this conference. I would like to thank also Samir Djouri, who is the president of this conference. Thank you also to Dr. Khalid Benzakour, who is the chair of the organization committee. And thanks also to a lot of people like Abdullah Lalawi, Hanan Gzir, Iman Shreyh, and other people. I can't forget the keynote and the tutorial speakers who come from several countries in the world. In spite of the heavy agenda they have, they accepted to come to Morocco to give us interesting talk like you will see after. Also, without the authors, this conference will not be possible. You did a good job, and all the papers who have been selected are very good. So thank you for the work you did. Also, many thanks to the committee program. Some people of the committee program are present here, in the room today. They did a good job. The reviews was not just one line, as we can find in some conferences. So thank you very much for them for the work they did. I give you some details about and figures about the submissions. Each submission has been reviewed by 2 experts in the domain, at least, and at most by 5 people. 5 because it was the process of bidding. Some experts decided to read and to review some interesting, they considered that the people interest them, so that is why some articles have been reviewed by 5 experts. As in any conference, each article has been weighted. We give a score to each article depending on the originality, on the idea, on the modelization, and things like that. And the best paper, or the highest score, was 35, and the worst was -13. So all the articles that get more than a score of 16 have been selected for the publications in this proceeding you have in the bag. And then the 10 best papers will be published in the journal of ISGA. People who are concerned by this information already received the notification, and after the conference you will receive some instructions and the template in order to complete your article, to extend your article in order to be published in this conference, in this journal, sorry. All the accepted articles of this conference will be published on the website of ISGA and on the CNRS Open Archive, okay? Some details about the program. We have 2 days of conference. Today we will have 3 keynotes. The first one will be given by Professor JEAN-PAUL HATON, and the second one in this afternoon by Professor Yves Lepage. And we will have 3 sessions. 2 sessions will be dedicated to speech recognition and its application, and one to machine translation and language modeling. And tomorrow we will have 2 keynotes and 1 tutorial. The first keynote tomorrow morning will be given by Dr. Olivier Sion from Google in the United States. And the second one will be given by Dr. Ahmed Zitouni from Microsoft United States also. And the tutorial given by Professor Karim Bouzouba from School of Muhammadiyah in Morocco. And we will have 2 sessions. The first one about Arabic dialect processing, which is an interesting topic, which is a challenging topic today in natural language processing. And another session about dialogue and information retrieval. As I told you, we have a heavy agenda during these 2 days. So for the keynotes, we will have 45 minutes for presentation. and 15 minutes for questions. So please try to respect the time allocated to you. Maybe for the keynotes it's not complicated because we can discuss, but for the ordinary presentation you have only 15 minutes and 5 minutes for questions. So I will ask the chair of the session to cut when it is necessary, because if you don't want to sleep here at ESGR, so please respect the time we give you. So in order to do that, what I propose is that you upload your presentation before your session, during the coffee break or after the lunch break. So just before starting, come here, you will have a laptop and upload your presentation in order to be on time when we will start. The lunch today and tomorrow will be in the surrounding area, not far from here, 100 or 200 meters. And we will go together for people who paid for that. For other people, if you would like to eat with to have a lunch with your colleagues, so go to the desk on in the reception and ask for the necessary things. And so I will give you an appointment in front of the entry of this building. We will go together with the students of this school. And before that, we will take the picture of ICNLSSP, which is very important for the conference. We will put it on the website of the conference. So some details about connections and social media. So you have 2 points of connection. You get them, you already get them. And you can follow, the conference on YouTube, because I hope that you will stay in this room. But for all your students or your colleagues who participate to the article, you can give them the link to follow this conference. And of course, you can have a lot of information at this hashtag concerning the conference. Okay, so I have finished my presentation. So we can maybe go to the scientific part after all these details. And before asking Professor Jean-Paul Haton to give us his presentation about artificial intelligence, let me tell you that it is my pleasure to introduce Professor Jean-Paul Haton. How to present Jean-Paul? You have to know that Professor Jean-Paul Haton held several functions in his career, so it will be it will take a lot of time if I give all the information about his career. So Jean-Paul, forgive me if I don't give all the details. I will focus just on few important points. Jean-Paul Haton is an emeritus professor today at the University of Lorraine, and he is a senior member of one of the famous French Institute Universitaire de France. He created the first chair in computer science in this institute. He was one of the members who created the L'Oréal Labs. Today in this laboratory we are more than 450 people in this lab with all the topics concerning computer science, from theoretical computer science until robotics and a lot of things. Concerning the topics of his research, he is an expert in artificial intelligence, and of course he had not started the last few years as a lot of people starting speaking and talking about artificial intelligence. He started in the beginning of the 1970s, and he was right about that, about the future of artificial intelligence. He is expert also in speech recognition, signal processing, speech understanding, and all things related to speech processing. He supervised more than 100 PhD students. And some of them are here in this room, starting by me. He was my PhD supervisor. You have Dr. Olivier Sion from Google. He was his supervisor also. Ahmed Zitouni from Microsoft. David Langlois also is in this room. It was a pleasure to work with him. And it is always a pleasure to listen to him again and again. So thank you very much for accepting to be with us in this conference. So thank you very much, Jean-Paul, and please.
Shukran Si Kamel. Assalamu alaikum. It's my pleasure to have the first presentation this morning. I would like first to, you know, my relationship with Morocco are more than 70 years old. And my relationship with ISJ is not so old, but not that bad, at least 20 years. It's my honor to be the first, to give the first presentation at this conference. I would like to congratulate the organizers, Si Mohammed and all the staff, Si Khalid, and all the staff of ISJ, and to thank my friend and colleague Kamel for inviting me. It's really a pleasure for me. Most of us are specialists of speech and signal and language processing, but Kamel asked me to give a more general presentation of artificial intelligence, so it will be kind of a recreation for you, in a sense, before starting to work after the second presentation. So what I want to do is to give you an overview of artificial intelligence right now. So let me... This is the outline of my talk. I will give you a brief introduction to artificial intelligence, then talk about the recent successes. You all know them, so I will just briefly comment them. Then have a look at the various approaches to artificial intelligence, namely symbolic ones and the digital ones. And then we try to conclude in this fastly evolving domain. First, what is artificial intelligence? When did it begin? In fact, the start of artificial intelligence was in the mid-50s, 1950s. And it started with a NATO summer school. Many of us know the summer schools of NATO. And artificial intelligence started with such a summer school, and it was with young researchers, which was very ambitious. They were very ambitious, since what they said is that they made a conjecture that every aspect of learning, or any aspect of intelligence, could in principle be so precisely described that a machine can be made to simulate it. You know, more than 60 years ago, young researchers, PhD students and so on, had made this conjecture. Of course, nobody succeeded in demonstrating this conjecture, but nobody succeeded in showing that this conjecture was not wrong, was wrong. So maybe one day we will be able to demonstrate it. Anyway, right now, we have several aspects of intelligence which are simulated on machine, not all, but some of them. So this was really the starting point. How can we define artificial intelligence? We can ask to one of the guru of artificial intelligence, which was John McCarthy, who unfortunately left us some years ago. And he said that the artificial intelligence, he was in the Stanford University in California, which is one of the best place for AI. It's at the same time a science and an engineering domain for making intelligent machines. And even this definition dates from the I would say, the early 70s, you know, or at least 40 years ago. And even at that moment, McCarthy, who is working mainly in intelligent computer program using logic and this kind of thing, he said that artificial intelligence makes also us to have, make it possible to have a better understanding of human intelligence. And even at that time, he said that AI does not have to confine itself to methods that are biologically observable. So it could be, you can use biological evidence to build an AI system, but it's not the only way. In fact, that's exactly what happens right now. Some word about the recent successes of AI that you certainly all know. Of course, chess was the Deep Blue of IBM. In fact, Deep Blue was a machine specially built for chess and with an enormous memory of plays and so on. But it was also mainly using artificial intelligence in his play. Then another interesting step was the Watson system, still from IBM, who was the best at the TV American play, which is Jeopardy. Jeopardy is a play in which it's a system. It's a game in which you don't have to ask to find the answer to a question, but to find the question given the answer, which is much more difficult. And at that play, Watson proved to be much better than the two best specialists, Ken and Brad, and you see the final scores. Watson was really the best. So, and Watson is not only used for playing this game, but now it is used to help decision making in medicine, in bank, in finance, defense. So the successes of Watson are really used in almost all domains of activities. Then we had the Go. I should say 5 years ago, I would tell you that within 20 years, computers program will be able to beat the best Go players. It's what happened in 2016 and not 2020 or 30. So once again, the artificial intelligence methods made it possible to beat Lee Segel, and it was the only time when a program was better than man. But after that, we had other competitions, and every time the machine proved to be better. And it's really impressive because the space of Go is so large that it's absolutely incredible that a machine could be the best human player. Another domain is also poker, a domain in which the intelligence is important, but coupled with some statistical aspect. And at that play, a program from Carnegie Mellon University proved to be better than human. And it proved to be really impressively better. You can see here, Librettus, which is the name of the system, won more than $1 million. It's false dollars, of course. Theoretical dollars, if you want, paper dollars. And the best players, where are you? Well, if we have brackets, that means that you are losing this amount of money. So Librettus win more than $1 million, and the human players are losing this important point of money. Now, which is interesting that in Librettus you have both artificial intelligence aspects in a logical form and statistical aspects also. And another domain in which the artificial intelligence is absolutely present is the autonomous vehicles. You see here a Google car. I took it because they were the first, not to be pleasing my good friend Olivier Suran, but because there was almost the only one first working on this. And right now, almost all automobile makers are working on this. Even as when the American one and the European ones. Everybody is working on autonomous vehicle. It's an interesting example. I will spend some minutes on it. So you see here's the Google's car. And I don't resist to the pleasure to show this. It's me here. And I have had the pleasure to enter into a Google car. A car without comment on dit le volant? Olivier? Voilà. Thank you. So, and you can meet such cars in California, in several cities of California. They are in the traffic, and they apparently don't have any problem to be in this traffic. It's an interesting example. Well, because here you see what Google car, which here, not only a Google car, a autonomous car is seeing. They see trees, people, cars, and they plan their trajectory. And to do this, an autonomous car needs three components. Of course, very good maps, then sensors, that is basically the important part, and artificial intelligence. Without artificial intelligence, it doesn't work. Google Maps, of course, you have very interacting and very precise maps with the speed limits, intersections, you report on traffic, and so on. You have a lot of sensors, especially LIDAR, which is certainly the most important one, which gives you a very precise idea of the scene around the car. And you have artificial intelligence. The system on an autonomous car is kind of an autonomous agent. And the goal of this agent is to drive a passenger to a requested destination, given by the passenger, in a safe and legal manner. And to do this, the system, the agent has to take decisions on planning, trajectory, on prediction, then at which level you have to accelerate, when you have to slow down or stop. The steering also is not easy. In all these activities, artificial intelligence is important. And the role of training, is very important. I will go back on training later on. All this is, as you know, due to the loi de Moore, Moore's law. That is to say, from 1970 to 2020, and maybe and beyond, the complexity of the chips are increasing, are doubling every 18 months, and it will have a limit, of course, which is not exactly reached, but almost. But right now we have more than 10 billion chips on transistors on a chip, and that's the reason why we can imagine such complex algorithm. Without that, if we had the machine of when you prepare your thesis, Kamal, that we do it not so old, but it was so far enough in the past for forgetting all this. We can have such intelligent system because we have the power in the machine for doing it. Otherwise, we will not do it. It's not sufficient, but it's a necessary condition. So let me give some words about the approach to artificial intelligence. The first publication on this topic was in 1950. It was by a person who is really a genius of the 20th century, Alan Turing, an English mathematician, who wrote a paper in 1950, Computing Machinery and Intelligence. And in this paper, Turing said, I propose to consider the question, can machine think? It's really to be visionary to do this, of course. And I cannot answer the question. I cannot give the proper answer. Nobody can give it right now. Maybe it's not true. Perhaps, I don't know, Frank, you're not going to be maybe a machine will never be able to think. Maybe it will. In some precise circumstances, we can say that the machine thinks. Generally speaking, maybe right now it's not true. But starting from this question, of course, the beginning of artificial intelligence was really mainly logical ones, because if you want to think, you think immediately on logical reasoning kind of thing. So that's the reason why we can say that the first approaches to artificial intelligence was the idea to make a mind with people like McCarthy, I only mentioned, Marvin Minsky, Alan Newell. And we are in the domain of what we call symbolic AI, and at some moment in history, we talk about expert systems or knowledge-based systems. But almost at the same time, we had people who had tried to build an AI system by modeling the brain, which is the alternative way of doing things. With people like Frank Rosenblatt, Michael and Pitts. And we can talk about connectionist AI and the so-called neural networks, which are very popular and very efficient right now. We can also say that the main development of AI are using statistical models. I mentioned it for the poker system, libraries, but it's also true for speech or for other systems like this. So we can say that there are basically two approaches to artificial intelligence, if I want to summarize. The first one is to build systems which explicitly use knowledge, and the second one is to build systems who explicitly are digital, basically digital. In both cases, one important feature is learning and training. It's certainly the most important part. People talk sometimes of weak AI versus a strong AI. Weak AI, that means the system that we are presently building. They are intelligent in very limited domain, and strong AI means that maybe one day we'll have systems that are more intelligent than humans, that is, are intelligent in all domains. But it's for tomorrow, or tomorrow after tomorrow. So let's talk about symbolic knowledge, the system, d'abord, first. Intelligence in knowledge, and knowledge is the domain in which you have many applications. In Loria, you mentioned Kamal's laboratory. Many people are still working on knowledge representation, knowledge reasoning with objects, ontologies, and so on. Project like Psych in the US try to model all the human knowledge in this framework. We had inference engines that was known in the late 80s, at least early 80s and late 80s, 1980s, I mean, with the so-called motor d'inference inference engine. And then we had the first inference engine was in the late 70s, as you see, with the Mycin system for medical diagnosis, to Watson, I mentioned in a moment. And there have many other systems in medicine. I just mentioned one because it is really very efficient. All these systems are still in operation, sometimes in routine operations, but it's only one aspect of AI. Question answering system like Watson, I mentioned, and other one are also an important aspect. And one important feature of this domain is related to big data. There is an increasing production of data in the world, on clients, on patients, on suspects, depending on the domain. And all these data are mainly ill-structured or totally unstructured, which is So that means it is very difficult to exploit them. And it's almost impossible to exploit them by hand. So that's the reason why we had a lot of projects trying to mine this data in order to extract knowledge from the data. And we have also, hopefully, we have the data, huge amount of data. That means that we have the possibility of learning from this data good examples. By the way, I just mentioned I will talk about the ethical aspect in the fast at the end of my talk. There is a problem of personal data protection. For instance, when you talk, when you use Siri in your telephone, maybe you use it, you are recorded. Nobody tell it to you, but you are recorded, and your speech is used for something which is very respectable, which is to enhance the HMM, the Markov models that are using for this. But nevertheless, it's a kind of privacy problem. You are recorded without that. As you said, the French ministry, à l'insu de votre plein gré. In a sense. Another interesting aspect of the domain are the social networks. You all know this network. You use them. I like very much this cartoon from Steiner. In 1993, he told exactly what is the social network. On the internet, nobody knows you are a dog, so you can say, you can do whatever you want. Nobody will know that you are, who you are and what you do. You don't agree, Khalid? You don't seem to agree. Okay, so why is artificial intelligence important in it? It's just because social networks are graphs, or we computer scientists, and especially artificial intelligence, are very good in exploiting graphs and in finding paths in graphs. This is typically a social network, and especially you can carry out breadth first search in graphs. You are here, you have your friend, the friend of your friend, etc., etc. And if you find path in this graph, you can have exactly the type of activities you have in a social network. So it's obvious that artificial intelligence has a role to play in this. Well, the second aspect of second approach to AI is the digital one, and it's certainly the most famous and the most efficient right now. The idea is to mimic the biology. You know, the biological neuron. There are several types of neurons. You want something here. You have not only neurons, you have also groups of neurons. For instance, the cortical neuron. We have worked in Nancy on this model for a couple of years, the people like Frédéric Alexandre. And these models have reality, biological reality, and more they have a digital and a computer science reality. The first model of the neuron was proposed in 1943, which was long ago by McCulloch and Pitts, and this is still right now the basic neuron that we are using. It's surprising that 70 years later, we have found a really better basic model of neuron than this one. After that, we had the perceptron, of course. I will talk about it a bit. And these were the beginning of the neural net-based approach of artificial intelligence. One interesting aspect of this of the neural network approach is what is so-called probabilistic parameters, which are really widely used in pattern recognition. The idea is a multi-layer perceptron with an input layer, an output layer, and one or two hidden layer in between, such a perceptron can approximate the a posteriori probabilities of classes of patterns that you are using, they are studying. Classes could be character, speech, clients of a bank, etc. To all types of patterns. Example in the speech domain, how to use these parameters. The first one was proposed by Morgan and Boulard a couple of years ago, which consists giving the speech input to use the output of a multilayer perceptron as input to the HMM that you are using for speech recognition. That is to say, you replace the Gaussian mixture that you have in the state by the output of multilayer perceptron. That proved to be efficient, but not that much, not very really better than the Gaussian mixture or Gaussian mixture. The second solution, which is the most efficient one, is to use these probabilistic parameters as complementary parameters to the HMM. That is to say, you have still the speech, the spectral parameters, then you are using the output of the MLPs as complementary data to the Gaussian mixture of the HMM states. And this proved to be really the most efficient one of using MLPs. After that, work was a little bit stopped and appeared what we call deep neural networks. That is to say, neural networks with what I call depth inflation. That is to say, we have no longer one or two hidden layers between the input and the output, but we can have up to 100 of layers. I don't know, Olivier Sion will talk about this certainly tomorrow, so it will give you the up-to-date information on this aspect, which is very important. And that means that we have up to billions of hidden nodes in such a system. So that means it needs a lot of data to train such systems. We could handle such a system thanks to the evolution of learning procedure. In particular, at that moment, Hinton proposed to have a semi-supervised learning of deep neural nets. After that, we had new methods également. Also. Deep neural nets are tractable for two reasons. First, because we have more computing power, still the Moore's law, and we have more training data. That's a conjunction of the two aspects that makes it possible to have DNNs, which are very interesting for a couple of reasons. There are a lot of variants, and Olivier will certainly talk better more than I do on this. And there are also extensions with the ReLU unit and so on. So I will not give more information on that. That's more the idea I wanted to show to you. This is, for instance, a DNN for speech recognition. We have still the spectral information, and then we pull this information to input layer of the multi-layer perceptron, and then you have several hidden layers before having the output layer connected to the state of an HMM. In fact, using a DNN with a large number of hidden layers becomes really rapidly intractable to the fact that we have very too much information to learn. Though a particular type of deep neural net have been very successful. It was proposed by Lequin, a doctorand from the Telecom Paris, and Joshua Benjo, my friend Benjo in Montreal. And the idea is to have convolutional neural nets. It was initially developed for speech, for image and vision, and it proved to be also very efficient for speech and other domain. The idea is to reduce the spectral variation and to reduce the number of parameters to learn by computing correlation. The idea is very simple. You have the input data here. You take a small image and you correlate, you make a convolution to obtain one aspect, one point of the first hidden layer, and then you do again, and so on and so forth. And you can also repeat for other hidden layers, and you obtain thus a complete convolutional network. There are many improvements. Once again, I will not talk about it since the beginning. And it's really, I could say, it's not really, I maintain the term, it's a revolution in pattern recognition, in speech, in vision, in character recognition, in natural language, in translation, Kamel also, and many other domains. We will certainly talk about this in the forthcoming sessions of this conference. This is an example of a convolutional deep neural net for character recognition, with the character here, the input layer, and then to make convolutions up to the output layer of these 10 outputs for the digit recognition. Typically, in a wide system, you have tens of millions of connections and hundreds of thousands of parameters to train. Though, once again, big data is necessary to train such systems. There is a double interest. First, you can learn more complex tasks. You can learn more complex, more higher level functions. And in a sense, you have some relationship with biology, which is interesting. That is to say, hidden layers can discover some kind of semantically meaningful structure. I'll give you an example here. I took it from a paper in 2013, when you have a car as output, an image of a car with some hidden layers, and you can see that from the low-level fixture extracted from the car, the hidden layers can extract some semantics of the image. That is interesting in that sense. The historical perspective of neural net is very interesting. We start in the late 60s with a perceptron, one-layer perceptron, Frank Rosenblatt. And then with only two layers, one input layer, one output layer, it was possible to do linear system with this. And in 1970, Navin Minsky and Simo Papert wrote a book that totally destroyed the research in neural net. That was the end. And it was really the descent aux enfers until 1986, when three persons, Murat, Hinton, and Williams, a PDP group, wrote a book and proposed with Yann Lequin in Paris the backpropagation by the gradient descent by backpropagation. And that moment, we skipped from a two-layer perceptron to a three-layer perceptron, input layer, hidden layer, output layer, and which was trained by backpropagation. That was really the good years of neural net. But at that moment came Vapnik, when this support vector machine, which is kind of a neural net, and once again we forgot neural net because it was not so interesting. And again, in 2000, deep learning came with Hinton and then Lequin, which made it possible to have not only 3 years, but almost as many layers as you want. And so we are increasing, and I don't know where we will go. Maybe we'll have another red lines at one time, but right now we are still increasing. We think in the green line, if you want. Here are the neural net. I will go rapidly. It's the same historical perspective for speech or character recognition. It will be the same. He made his thesis on this character recognition. From the time warping to hidden Markov models, mid-layer perceptrons, Gaussian motors, and deep networks. And from 2006, DNN are almost present in all systems. Dynamic programming is still there, but DNN also there. Okay. Many applications of DNN. Kamel, tu me dis si je déborde là? Non? Ça va, it's good. So I tried to put some application, and I was only restricted by the size of the slide and the size of the police. I could do much more, but that's enough to see that the DNNs are almost everywhere in the sales aspects, in medicine. Very nice. People are trying to build chips, neuromorphic computing at the nanoscale level. There are very interesting works in Paris on this. Some companies, like NVIDIA, GraphCore, or Cambricon in China, are trying to build chips with which incorporate neural nets in them. Marketing, banking, people are saying that neural net with revolution banking. We were talking of this morning with Olivier and Imad. We are not sure it's true, but people think it is. It will come. Car driving, the training aspect of automatic system for car is very important, and it uses DNN. In the forensic activity also, in image processing, in natural language processing, we're starting to talk about this in this conference. Also in translation, maybe, Kamel, we'll give your opinion on this. In speech synthesis, it's not only the best speech, text-to-speech synthesis system is based on DNN, emotion also, and of course in the image processing domain. Certainly, it started from this domain, and it's still very, very effective. Frank Poirier will tell us that using speech for interaction is not so interesting that it could be, but you will hear your opinion on this. Before concluding, I'm trying to take some altitude and to talk about some aspect, generally speaking, of artificial intelligence related to ethics. This is a question which is already addressed from computer science. What is the importance of optical aspects in computer science? There's a very interesting report from CNRS. I was one of the persons who worked on this report. That's not the reason why it is interesting, but it is more generally interesting because it addresses this aspect of which are not so often taken into account, which is how much ethics should we incorporate in our research and development. So I give you the advice to read this report, which is already available for free. Artificial intelligence introduces new aspects of ethics, which are not really in computer science. First, I'll try to give you some of these aspects. The first one is related to the danger that can provoke artificial intelligence systems. You know the 4 laws of Asimov for robots. A robot do not make any hurt to a human, and so on and so on. Maybe with AI system we'll have to revise the Asimov's law. Certainly, not maybe, certainly. Then we'll talk about the moral status of machines and the quality of such machine due to the fact that we have more and more a social and a medical role. So it's absolutely necessary to control the predictability of this machine, to have the transparency to inspection. It is absolutely necessary to know why such a system can give such advice. Otherwise, it would be very difficult. Some people are working on ethical decisions of machines. There's a group at MIT who developed the mirror machine aspect, which is very interesting, and you can go to the site of MIT and see what they are doing. Very interesting. Then we have what we call the singularity, what people call the singularity. It is the moment where automatic system could become more intelligent than humans. Will it happen one day? I don't know. But if it would happen, it's necessary to be very cautious on this. If you have a machine with super intelligence, superhuman intelligence, you imply that such system has an over or super ethical behavior. Otherwise, it could be very dangerous for man. Well, that's not science fiction. It's future, just future. People are working on the aspect of, do AI machines or AI systems have a conscience or not? There are a lot of interesting work on this, and I see we will see in the future very many publications on this aspect. That's for the future. Then it's time to conclude. What can we say? I said that artificial intelligence has broadened the field of informatics for a long time. And Kamel, you mentioned people from Loria here. For a long time, artificial intelligence has been considered very badly by the computer scientists, especially at a very famous French institute called INRIA. Actually, officially, INRIA was against AI. I have suffered from this for years, and I'm happy to see it. In fact, right now, logical knowledge-based system seems to be outperformed by the DNN. Will it be the case for a long time? I don't know. Maybe. Anyway, researchers are still necessary, and research is very active in laboratory all around the world on knowledge and reasoning, on learning and training, which is certainly the most important part. Especially if neural networks want to be really the most efficient way for making artificial intelligence system, we will have to implement on such neural net procedures for learning how to reason and to plan activities, which is not really the case right now. That will be a case maybe one day. There are many research projects on the constituents of DNN and on the architecture. Right now, a DNN is still a perceptron, right? Nothing else. Maybe one day it will no longer be the case. There are very interesting works on, for instance, by Hinton on capsules, which is certainly an interesting way. The cortical column on which we worked 20 years ago in Nancy will be a good candidate for a new architecture of DNN. And such systems have also to learn how to handle uncertainty, which is certainly a very important point, and it is not very well taken into account in the DNN. And once again, it's absolutely necessary to take into account aspects which are not now a little bit neglected by researchers or professionals, which is the ethical and the political aspect of this. Because if such systems are to be more and more intelligent, we have to be very, very cautious on this aspect. Well, it's the end. You know, we have to be cautious also on the quality of prediction in the future. You see here what people thought it was in year 1900, okay, en 1900. What was the year 2000 for these people? You had the professor, he took the book, he put the book in the machine, there was a pupil turning the wheel here, and people learned automatically the content of the books. That's very interesting. There are not it's not exactly the case right now, but the headset was already invented, you see, which is not that bad. in year 1700, they invented the headset, which is the difference right now. They no longer wireless headset. Thank you very much, Shukran.
Thank you very much, Jean-Paul, for this interesting talk about the past, the present, and the future of artificial intelligence. So we have plenty of time for questions. So do you have questions? Yeah. Can you? Could you have mic?
Bon, si vous parlez assez fort, peut-être, non? Ah oui, il y a un...
Thank you. I have three questions, actually, three remarks. The first one concerns one aspect you didn't talk about, which is the programming language concerning AI. I studied in '90, and you know, at that time, Prolog and Lisp were very famous.
Yeah.
I'm still teaching this language, but I see that students are suffering because of these new languages that are launched by Google, etc. So. I would appreciate having your feedback about the what is your...
à la première question tout de suite.
Go ahead, please.
So, yes, of course, and you had 20 or 30 years ago, you had the Lisp machines. Not only the language, but the language implemented on a machine. The Japanese choose a Prolog as a language for fifth generation computer. And I have the pleasure to take a vote about my friend Alain Kormeroer, who died some years ago, not far, 1 or 2 years ago. He was the father of Prolog. Right now, I should say all the AI systems are written in C, and all these language of which was supposed to be devoted to AI are almost forgotten. What is the reason? Certainly the increasing power of computers.
Okay, thank you. The second one is it seems, I think you addressed this point sometime at some time in your presentation. We have a sort of vertical intelligence, all what we are building so far, right? While the idea is to build a sort of horizontal intelligence. If you take Watson, if you take Deep Blue, all of them are extremely vertical.
Absolutely.
So
narrow AI. So you want how about strong AI for tomorrow?
For tomorrow. Okay. The third point is the.
Larsen c'est du Larsen, c'est sûr. L'interaction entre les. On va peut-être arrêter celui-là.
The third point is the okay, you're welcome. The third point concerns we are all trying to reach a sort of optimality. Okay, this is the core of computer science. We always try to be optimal as much as possible. If you want to be which means here it's like it's AI. The objective of AI is to simulate human intelligence. We suppose all human beings are so intelligent, and this is what we would like to reach. while people are not always intelligent. Why are we reaching something that is not feasible? As computer scientists, we try always to be more optimal, more optimal, more optimal.
Thank you, Mark Hasegawa-Johnson from the University of Illinois. I want to point out. So I want to issue, I guess, a caution. The people in the field of computer vision have a tendency not to cite papers from any other discipline, and as a result, they get a great deal of press in the New York Times and in other major newspapers, thinking that they invented everything. Cite the people who actually invented it. So in particular, since this is a conference about speech, I should point out that convolutional neural networks were invented in speech. They were invented by Les Atlas in a paper in 1988 on phoneme recognition. So okay, so you gave credit to LeCun and Bengio, and they deserve credit for continuing to research on this for 20 years. But in fact, the idea did come from speech originally. Oh, okay, I missed that. Thank you. Yes, but it was first invented in speech. It was first invented in 1988 in a phoneme recognition. In 1988. Yeah. Thank you.
My remark is close to the one given by Professor Karim Bouzouba, but not languages, but about research itself. Today, if you don't do DNN, you are not a researcher. So it is very complicated today if you develop a speech recognition system or any other thing, this kind of system, if you don't compare to DNN, you are nothing, and your publication will not be accepted. So do you think, for me, it is said that everyone does the same thing in the same way, in the same direction. Yeah, I know that. We have, because you have this experience with HMM and today with DNN, so should we, all of us, work on DNN, or, because of course, I have my opinion about that. I'm doing, in several research, I did things differently from the other people. But I think that we have, because today in DNN, we know a lot of people who are doing, they are churning parameters. They are not doing research. When you have the platform, just turning with the parameters. So I would like to have your opinion about this way of doing research.
Against it.
So before going to the coffee break, I would like to thank Professor Nadoromi, who is the representative of University of Hassan II, who accepted to make the opening session today and to give us to talk and to give us few words about this conference. So thank you very much for coming, and thank you for everyone. So we have half an hour for the coffee break. You can continue discussing with Jean-Paul and other people.